we still have to recall. Topic number 2, it's all about the operating system. Sequentially, operating systems. Sequentially, we said we have how many topics? We have around 11 topics. From the introduction part, I've highlighted as well all the topics. And again, what I've done, I've highlighted for you the revised topics and those still who, which belong to the old syllabus. This is just for us to be able to fast track the questions or the possibility of questions. At least that's how we play the game. And then another thing is that I told you when we were doing topic number 1, I mentioned introduction to computer softwares. And then from the illustration that we did, we saw that we have system softwares which are now carrying a branch of like 3 or 5 types of different softwares. And one of it was the operating system. From the introduction, I told you by mention, the operating system is also known as the resource manager. And then, remember, when I was doing the illustration for the hardware, I had this diagram that looked like a sketch with around 4 to 5 rectangles when we were looking at the tangible devices of a computer. Then we say we have a very key type of component that we normally call it the central unit, or else you can call it the CPU. Over here we said these are just segments, or we can call them allocations within the central unit or within the CPU, whereby we have these 3 types of hardware components. And the main concern, I told you, in as much as the machine does the execution for us, we always look up to the CPU. When this is dead, then it means we don't have a machine. When the CPU is no longer functioning, then it means we don't have a machine. And why is it so? We say this is the brain of a computer, this component or this hardware device, the CPU. And then, of course, these ones you will get them from the introduction. Our main emphasis of today is to illustrate and just pinpoint out why we are calling now the operating system as a resource manager. Remember, this is just one type of the softwares, but it is very key, it is very crucial. Even in our smartphones, when your operating system is dead or it's no longer functioning, then you don't have a smartphone. You can no longer call that a smartphone or a phone. It's gone and it's gone. Reason being, that is what we are going to find out. So let's move on. What is an operating system? What is an operating system? We can simply define it, then we look at the views. An operating system is a program, or it's a part of the system softwares that manages and controls computer resources. It is part and parcel of the system softwares in a computer that can manage and control the resources of a computer. Thus, we call it the resource manager. From the term controller, it also becomes a resource manager. We can also define it and say, an operating system is a program that is able to act as an interface between. An operating system is a program that is able to act as an interface between the users and the computer hardware. It acts as an interface between the users. The users, it's me and you. The users of the information system we are looking at currently, we are looking at myself, because we have to interact with the devices. as much as I'm in this class, you can be able to hear me. I'm also being assisted by various devices to host the class the way it is. All that set up together to the point where it is being accomplished, I have an interface. And what is that interface? There is an operating system present. Of course, the versions comes in different setups. The operating system for various or variety of activities. So to cut it short, is an interface that enables we users to interact or get connected to what we are calling the computer hardwares. Be it the keyboard, you can look at the mouse, you are connected to the CPU like we did with the drawing, you are also connected to the monitor, any other device. For you to access that device, you need an operating system. So in a nutshell, operating system is a key interface when it comes to computer system. And then I've mentioned the word interface. Let me highlight this for the sake of continuity. We are going to be using this word almost in every concept. We shall be using it over and over. In its own, what is an interface? What is an interface? An interface is one of the emerging fields in ICT or emerging concepts. Concepts, these are fields that are still being discovered or they are rolling out. That's how we call them. So this interface is a link. It's a bridge. Just leave at that point. It's a link. It forms a bridge. Hence the name interface. And also from our introduction, we mentioned that since we do not have a lot covering emerging issues in ICT, we agreed at the back of our books, we will be writing some short summaries on the emerging issues in ICT. And already today we have one emerging issue, which is interface. I think I have around 10 or 7, so we'll be listing them as we move on. So an interface from today we know is like a bridge, or it's a concept that we are using to imply the link between one side of an aspect to the other side of an aspect. That's what it means. So let's understand the views of an operating system. Views of an operating system. How many views do we have? As long as we are looking at the operating system, we have 2 good views when it comes to the operating system. View number one, when it comes to the operating system, there is what we are calling the user's view. Number 1, users or the user view. What is a view? Those who like going for adventures, especially on, or maybe to those escaping places in quotes. For example, those who like going for hiking to long or higher altitudes, mountains, etc. When you are at the top, what do you normally observe at the low level? Of course, there is the view of how maybe the valley looks like, etc. So that same view is the one we are bringing here. There is how you as and I as the users, we have a particular perception in regards to an operating system. That means, as a user, when I look at the operating system, for me, it acts as an interface. Let's mark the keyword there. For the users, the operating system is an interface. As a user, I repeat again, the operating system acts as an interface. And what have I just said in the other explanation, especially for definition of operating system? We have said an interface is a link between who? The user and the computer hardwares or the components of the computer. So when it comes to this view, I am a user of the information system. I am a user of the computer. I will view the operating system as an interface. Reason being, it connects you to the machine. It is the bridge that you need to connect to the machine. For me to operate this machine, there must be an operating system present for me. So in its unique nature, why do I need an interface? Because at the end of the day, I have to access and get all the resources of a computer. I need to access, I need to work, I need to have access to the resources of a computer through an interface who is now the operating system. Number two, there's another view when it comes to an operating system, and that is the system view. I know it's getting a bit complicated because now we are looking at operating system. And then how come the system itself has a view? Yes, it has, because at the end of the day, the system also needs to reach us, the users or the clients. I'm standing here, before me, it's a workstation. This workstation is made up of, or it's a computer in nature. For it, as a machine, it will need an operating system to access myself as a client, as a user of an information system. Why does it need to access users? It needs to access the users so that users can now take the resources or can access the resources. So in short, the system view towards an operating system is that the OS, as we normally abbreviate it, OS, is a resource. It is a resource allocator. I want just to simplify the terms that are really necessary for us to understand what we are discussing. So from the system view, the operating system now becomes a resource allocator, meaning within the computer system, we have so many resources. Resources like, number one, we have CPU time. I'm reminding you again on the many resources that we have within a computer or within an information system. We are looking at the CPU time or the machine time. We are looking at the memory. We are looking at data also, which is somehow resident in the machine. We are also looking at information. We are also looking at any other products that we may need from a computer. So to that machine, the operating system must be present to serve us, the users, with the resources. That is why the system regards the operating system as a resource allocator. Let's further understand more in terms of managerial duties. Why do we call the operating system a resource manager? I'm trying to trace a question for you in the past papers. I think it's good. We move with our agreement, or we continue with our agreement. Remember, we said from today onwards, at least we'll be looking at those questions and then we work them out. We work them out. So I noted a question in relationship to the operating system. I think I came with the paper. If not today, then we may be lucky in the few minutes that are following. I also remind you that you need to have your college past papers link. This link is usually available as long as you are a student. You need to get it from your administrator. And again, it's a link that has a couple of questions, and I mean past papers for all the units. So as we are going through the functions of an operating system, the functions of an operating system, for us will be also checking and answering April 2022. This is how we do it, because we may not have time towards question 3. At your own free time, you will check at that question. It was done in April 2022, question 3. What are the different ways in which this question can be examined regarding the functions? They may not directly ask you to state and explain the functions, but they may prefer using some language like kindly elaborate why the operating system is referred to as resource manager. You may never know. They may also ask you, you elaborate why the operating system is referred to as resource allocator. From any of these angles, just we need to understand this. When it comes to the operating system, among many other functions, it must and it sits at the heart of the machine to fulfill duties that are closely related to that of a manager or a resource allocator. The two words there are very key. So in relation to that, when you get the past papers, browse that, just answer it from day one. So let's answer together that question. Functions of an operating system. Functions of an operating system. Someone told me they will think of controlling of resources, but this is a broad perspective. Which are these resources? We know there are resources, but there are so many. There are so many. The key word there actually which has guided us to this question, it's all about resource allocation. So number one, I can talk of input, output, allocation, input, output, allocation. That is just one function, still under the resource allocation. Input, output allocations. What are these form of inputs that have to be allocated, and to who and to why? What are these outputs that needs to be managed? When we look at this functionality, we specialize with what we call input-output device allocation. Because at this point, remember the drawing that we did with the computer hardwares. We had an illustration from this end where we have input devices, communication, we have the CPU, we have the secondary storage, we have the output devices. Then I told you to monitor that drawing because it will be key for us when we will be undertaking operating system as well as understanding the booting process of a machine. So it is the work of the operating system to ensure any components or when the users are in need of input devices, they are assigned to them. As well as within the internal system, within the internal components, any device that needs to be allocated an output is already assisted. For example, once the machine has been able to process your data to information and it is time for it to be distributed, who has to do that duty or to be communicated to an external device? Of course, it is the operating system. Function number one, input, output, resource allocation. You can also call it input, output, device allocation. Those two terms, they will still assist you. Number two, operating system as a duty or function in handling the CPU time. Handling CPU time. It is the work of the operating system to manage and run resources within CPU, especially that vital resource we are calling time. It does that function by monitoring CPU idleness, okay? It manages CPU time to avoid idleness. That is to say, it is there to allocate timing as how CPU is supposed to function. What does it mean? When the jobs have been already delivered to the CPU, jobs may be the instructions for the machine to execute. When they have been delivered to the CPU, it is the work of the operating system to allocate or to monitor and utilize CPU time in handling each and every duty. Let's say there are 5 tasks. One requires 2 hours, the other one it requires 5 hours, the other one we have 2 minutes, we have 3 minutes, we have 30 minutes. It is up to the operating system to verify all these jobs and again, go to the CPU and manage that time. How does it do that function? Because we understand that machines are multitaskers. That's why we have the capability of a machine being able to execute one or more than 2 tasks or more than 1 task simultaneously, because the CPU is being assisted by the operating system on how to execute 1, 2, 3, blah, blah, like that in terms of the jobs. So that no particular instance, the CPU will be idle, especially in a busy environment. Number 3, we have job scheduling as another function for the operating system. Job scheduling, that is job queuing. The operating system, these two marry each other or they borrow from one another. When the machine receives instructions, let's call them the tasks or the jobs. As we've said, we have 5 tasks. We have 1 hour, we need, another one needs 2 hours, 30 minutes, 5 minutes, even close to 1 minute. It is the work of the operating system to act as a resource manager in queuing or allocating these jobs within the CPU itself. Just like the way we used to have the old types, old traditional ways of banking. What do we used to do? We used to go to the banking halls and then we would queue behind one another. Sometimes things would be messy or there will be a lot of customers such that we need, or the person, the bank assistants have to walk around trying to to arrange the queues depending on the needs or depending on the kind of service you are requesting for. Even nowadays, they have reduced the queuing through other methods, or of course through adopting technology, but still they have modernized in such a way you will pick your ticket and then it will assign you a queue or it will assign you an assistant based on the kind of service that you need. The same kind of sort of idea does apply when the operating system is queuing jobs awaiting CPU allocation. So it will check on the nature of the job, first of all, depending on the size or the volume. And again, the time requirement matters. So it will perform that queuing in the nature that at any particular moment, that job which requires 5 hours does not block the other jobs that need like even a second or even a minute. It does job scheduling by ensuring that all the activities, or all the instructions are being allocated CPU time, either in the nature of clockwise or anti-clockwise. It enables the CPU to tackle the tasks from either angles of the clock. It can start at the last one, it can jump back to the first one. That's how it alternates. Job scheduling. Number 3, sorry, this should be number 4. We have another duty, management of storage space. Of course, let me shorten this one, and I will just say it has a function in memory management. Memory management. Let's explain and let's understand how the operating system does memory management. Back to this kind of drawing where we have the CPU, then we have the central unit, We have the arithmetic logic unit, and then we have the primary memory or the main memory. What I can be able to show you, it is the position where the operating system might be seated at any particular instance. Reason being, we defined software as the intangible, or they are just set of instructions that are invisible. We can't see them, we can't touch them. Not like the way I can refer to this whole system and then I'm able to touch the tangible components. So it is invisible, but we are conceptualizing it and believing that it is present inside this computer system. This is our computer system. So in memory management, when the CPU, especially these two compartments or these two elements, the central unit and the arithmetic unit, when they are busy during the day and there is lots and lots of instructions to be executed. I know you work with a machine, especially towards the busy season or when you have a lot of assignment. All the time you will notice that your machine is under continuous execution of tasks. So at that particular moment, the operating system is all over, watching the CPU for utilization of the so many duties or the so many functions of the CPU. So what shall it do? Through its capability, and it is present from all the corners, through its capability, it looks and observes the CPU, especially to allocate or to manage the amount of memory which is resident here or it is within here. The reason being, when there are so many activities to be executed, if the memory is not managed properly, then what happens is like when you are trying to run, not like a machine, but when you are trying to execute a lot of tasks, what happens? Some will skip your mind, or some will be thrown out. Or let's say we are dealing with a boiling pot, and that boiling pot is full to the brim. When the fire is ignited and everything is burning up, some, because of lack of space, they will jump out. So to avoid that case happening with our work or with our tasks that are being executed by the CPU, the operating system must come in hand and assist their central unit to reduce the burden. And also, it must come in time or on time to reduce the exercises or the tasks that are within the memory on time. This is the time where it does memory management by looking at the extra instructions or the extra tasks that are resident in the central unit or the CPU and allocating them a buffer memory. Let's say the primary memory is very, very occupied and things are quite a lot to be done here. Operating system will look for other types of buffer memories and they will be called to assist. Most of the time, the buffer memories, you find that they are very temporal or they don't hold information for a longer period of time. They are only holding the information to assist in reducing the burden within this compartment or within the CPU. So when the tasks are a lot, the instructions are filled and filling in inside the CPU, the operating system has to do memory management by providing buffer storage areas that can hold the instructions or can hold the tasks for a temporal basis as the CPU is being or it's continuing with reducing and reducing its work. That's why we said we need to understand within the primary memory or the main memory is temporal also in nature. And we saw that one of the qualities that makes it temporal is because it doesn't hold the information for long. I'm just imagining if this was a permanent kind of a memory. most of the time CPUs will be bursting out. Reason being, can you imagine a machine processing everything and storing it inside the CPU? It will reach a point whereby the CPU has run out of space. That's why primary memory or the main memory is temporal in nature. It can only accommodate instructions during execution or when the CPU is at work. And once you switch off the machine or the power is gone, that information has to get somewhere else. That's why we come up with the secondary storage memories. A good example, still resident within the computer, is the hard disk. That means when this is full or during operation, anything that is finished, it has to be taken out and allocated now to the permanent sort of memory. Still, that is the work of the operating system to ensure any complete set of instructions are allocated a memory or a storage space. Hence, we add the fifth function, storage space allocation. Now, I am sure you can be able to differentiate between these two functions when we talk of memory management and when we are talking of storage space, because now storage space comes after the management of memory has been achieved. Storage space needed, it's needed for now keeping the fully completed tasks or the output or the information at the end of the day. Another function still for the operating system, another function, you have any idea? Maybe you can add. Another function, let's look at filing system, file management. And let me advise you, as far as ICT is concerned, in any matter or in any question, most of the questions target to have an input of around minimum 8. Minimum 8 points, because these are the questions that will award you more marks. The ones for 2 or 3 or 4, that's one you can gamble. But where we are needed to go to the highest, then it's a minimum of 8 points. File management, another function still supporting our argument that an operating system is a resource manager. Files, what are files? Files, they are the same. In physical scenario, we know the box files. The same way we have files in a system, mostly they are the folders or the many storage areas. Sorry, they are the databases, but I don't want to call it database. I want us to stick to the word file management. It's the work of an operating system to assemble or to collect your files and keep them together. Let's say today or in the morning you had like 5 spreadsheets, programs that you are working with for different assignments. The moment you create or you ask for a storage area, the system gives you a chance to create a folder, for example. Then in that folder of yours, you will, let's say you will place all your Excel sheets there. Who does the arrangement for you? Why is it that sometimes, even if you may be saving them in an order like the first one, the second one, but there's some sort of arrangement which happens there, especially following maybe some of the notable orderly arrangement in any scenario, like maybe alphabetically or maybe through numerical values. That is the operating system which does arranging and how we are sorting our filing system. Because at the end of the day, that filing system needs to be done properly for us to be able to access it tomorrow. So also, when it is doing the file management, it will not, what type of a file is this one? It gives you the nature of the file. It also adds more status like the time, the date, etc. File management. Number 7, we have another function that is on accounting and logins. Accounting and login. Accounting mostly comes in when it is looking at the perspective of arranging our files. It will take note of that arrangement. Also, accounting and login helps you or protects you when it comes to your work or the machine's accessibility. With accounting and login, it is the work of the operating system. Before you can do anything with your computer, once you press the start button, it will take like a couple of seconds, less than 1 minute, or maybe a minute or so, depending on the kind of processor you have, for the machine to display for you a blank, let's call it the blue screen, with a clear box asking you to key in a password. That particular scenario where you pressed on the power button to the point where now you are seeing that screen whereby you need to key in your password so that you can be prompted to the landing page of the machine itself. It is the work of the operating system to coordinate that, to make sure it identifies you. We can call it identifying. It makes sure it identifies you. Who are you today? Who is this? This is Grace. Grace, where is your password? You have to key in your password. That is the work of an operating system. I may be taking opinions from you also. Any opinion, any input towards that April 2022 question 3, why we refer the operating system as a resource manager or a resource allocator, or from our context, what are the duties of an operating system? Number 8, operating system does communication. It does communication whereby it allows all the components, it allows or it handles, or it's an interface between the very many devices within a computer system. For your keyboard or for your any input device, to make sure the instructions have been communicated to the central processing unit, then there will be need for an operating system. In other words, this is an interface for all sorts of communications within a system. It's an interface for all communication within, number 1, all the components of an information system and all the programs within an information system. It's a very major sort of system, or a very key kind of a software, because it handles communication when it comes to the hardwares. It also does communication handling when it comes to the softwares. For the other programs to communicate, they will need the operating system. The same way the devices, the hardwares will need the operating system. That is number 8. Number 9, we have error handling. Error handling. Error handling is another function performed by an operating system. Still, within our work, or sometimes, or most of the time, when we are typing documents, it is the work of an operating system to take an initiative to correct our work. Whenever we make errors, it is there correcting for us. If you have ever worked with maybe a Word document, mostly when you are typing, what happens? You will find that if your English version is differing with that of the ROM or that of the machine itself, there is someone who is underlining for you all through. And most of the time, you have now the spell checkers utility. You click there or you right click and then you pick the right word or the reference word from the system. Who is doing all that for us? It is the operating system. again, working and ensuring that we as the users, our errors are being corrected. It takes an initiative to make sure that our work is error-free. Number 10, let's talk about security function. Security. Operating system is very key when it comes to our security for an information system. Let's say this, whatever we are calling an information system, we agree that it is the machine itself. There's somebody who asked me, you are using the word computer system, you are using the word information system. Again, you are talking of system itself. What is the meaning of these three terms? And I told them, this is how we should understand it. When we are looking at technology, most probably we are attacking or we are tackling devices with all sorts of resources. But before we get to the resources, there are only two important, I can call them branches within any particular kind of a technology. There must be hardwares, we need to have the softwares. When these two come together, they form these three terms. They form a system, they form an information system, they form, the systems themselves. In other words, don't overthink. Don't try to bring rocket science here. Yet we are supposed to look at it from a simpler format for us to understand. I know later on down topic, maybe like 5, 6, 7 down the line, we will find more and more into understanding systems, in what systems. We will have more and more into understanding information system. But remember, at the end of it, it is all about technology with only two common or with two key necessities, that there must be hardwares, there must be softwares. So when it comes to security, how does this operating system perform as a watchman or as a security guard? It is the work of the operating system to ensure anyone who is visiting or logging in to your computer, they have to identify themselves. That is why after booting the machine, you can end up being a user with admin rights, or you are a guest. When you are a guest, most of the time you find that you don't need to have the login credentials. But if you try to log in as the owner or the administrator, you have to get their admission by proving you have login credentials, because the operating system has to take care of the security of that machine by controlling our passwords or our login details. Those are the functionalities regarding security. Let me also mention this. Practically, there are some utility programs which do not, or sometimes they conflict with the operating system, especially some types of antiviruses. You may try to run it and it will not be accepted. What is the cause of that scenario? You try to run an antivirus and then the system rejects. This is the reason. When you are running this program that you are calling the antivirus, remember you have the operating system for the machine. And if by any chance the operating system is not conversant or is not compatible with, in quotes, that type of the antivirus, then it will not pick, because it will suspect that is a malicious program. And what does it do? It will block its functionality or maybe its performance. So sometimes you find that there's a bit challenge in finding the right sorts of antiviruses sometimes to run on our machines or maybe to install in our machines. I've given you 10. We agreed minimum is 8. I want you to add 2 more functions in relationship to that question 3, April 2022. At least it will build more and more input at that particular instance. Now, let's measure into understanding the types. At the same time, with me today I have 2021, I have 2022. Let me see if there is any repetition of the same questions. Or say something related to topic 2 up to that point. Sometimes they do repeat. In fact, the next class when we are meeting, I'm still waiting for all of you to be settled in. I will run a particular session where we'll be just assessing the questions so that you can see how they normally repeat them or they exchange the topics. You find topic 1, topic 2 was question 1, it was question 4, it is question 7. Yeah? Okay. Let's look at the different types of operating systems. Types of operating systems. Somebody asked me whether an operating system is the same as the process. And I told them it's a no. Operating system, define it. It's just a set of instructions whose work is to manage the resources of the CPU. And what is the processor? The processor is the CPU itself. So you can't say that that program will qualify to be the processor. When we look at the processor now, we are looking at the central unit comprising of the CPU and the rest of the compartments. So let's look at the types of operating system. Number 1, we have batch processing. Batch processing operating system. Batch processing operating system. To understand the types of processors, the operating system, it's always good to quote an example. Another trick we are learning today that to make a kill or to just aim and score that distinction in ICT, you must be able to be thorough in explaining with related examples. That is where the catch is normally sometimes for us. Because being too shallow, again, in the way you handle the questions, and let's say that time or that time, or that day, your paper is being marked by an expert in the field. Do you think they will settle for shallow points or shallow answers? No, they will be looking at that particular, or they will be marking that paper with an expectation that you are an expert or you are a thorough candidate. Okay? I've seen many people being rebellious with the paper simply because I told them this is a technical paper, but we are supposed to write it theoretically. And where can we show that we are smart? It's being able to explain with deeper meaning of what we were writing. So when we look at batch processing types of an operating system, these types or these programs, they deal with batches. This is the word, batches. What they do is they execute tasks, or they are able to process information that is in batches. And a good type of a batch operating system, look at those programs that runs the payroll. Yeah, a payroll system is a very good example of a batch operating system scenario or a batch processing type of an operating system. Batch operating system means that it is capable of accumulating or assembling, that's the word I can use in quotes, accumulating the tasks. Then what it does, it will execute them with one cycle of the CPU. It does the accumulation of tasks, assignments, or jobs, and then it executes them with one machine run. And I've said an example is a payroll processing system. What happens with a payroll processing system? Let's take a span of 30 days, or even 28, or even 26, depending on your policy. All you do on a daily basis is to clock in. You have to sign in, you have to clock in on a daily basis for like 26 days in a month. Then what will the HR do? They will need just one cycle or one execution to close the payroll. That's what we are calling a batch processing type of an operating system. Then number 2, we have a time sharing. Time sharing type of an operating system. Time sharing operating system. There is the word time, there is the term sharing. That means this type of an operating system allows users, the term is, it allows users to share resources, or else time sharing operating system, it allows users, or it allows, I'm using the term users to show that there are so many. So it allows many users to share the computer resources, especially time. It allows many users to share the computer resources, especially the time. And it does so by allocating. It allocates them what we are calling the time slices. Time sharing type of an operating system. It allows many users to share or to access the computer resources by way of allocating them the time slices. Either, we have said, either anti-clockwise or in a clockwise rotation. One more time, let's repeat one more time. Time sharing operating system, it allows many users to access the computer resources. And a good example of that, those resources is the time. By allocating them what we are calling the time slices in either clockwise or anti-clockwise rotation. We have either, we have current, we have XYZ. All of us, we are allowed to share time, especially CPU time, by either a movement of, we have going forward, it's clockwise, backwards is anti-clockwise, such that every moment the CPU turns its hand on the right, it will touch on IDA's request. When it turns again very fast on the left, it will touch on current request. And mind you, what we need to note is that how CPU jumps from one task to the other. It is so fast, such that you will think you are the only user being served by that particular information system or by that particular machine. If, for example, we are to see or we are to use an application to send maybe an online whatever prompt or something. Let's say we have 2 or 3 machines here, and all of us are accessing that facility or that online platform. The moment I click send button, the system will be moving in a motion such that I will think I am the only user in that type of or that particular system, because there is an operating system which allows me or which allows all the users to share time slices. Next, we have a distributed type of an operating system. Distributed operating system. Distribute. What is distributing? Having numerous or various different locations. If I ask you within the city or within Nairobi city, we have so many estates or we have so many residential places that are scattered all over. So that scattering is what we are calling distribution. So what does this kind of an operating system achieve? This is this, it's this developed, or it's a kind of an operating system which can be able to manage a group of users or group of machines at different locations. And they will appear as if they are sharing a single computer. I'll repeat again. Distributed operating system manages a group of different computers. You can also talk of different users located at various places. They are not, centralized. And they make it, or they make them appear as if they are accessing a single machine. Most of the, when we had the COVID season, a lot of companies opted or adopted the remote style of working. That is, you can work from home. What you needed was just a portable machine or laptop. And then you, from your home, you are able to log into the company server. What is critical at that particular kind of a system is how that operating system is able to assist the server in allocating or accessing all of you from different locations as if you are a one person. Again, from the user side, you are scattered, but you are able to log into the company server because there is a supporting system, which is now the operating system, enabling all those scattered computers to access a single site and function as one computer. Distributed type of an operating system. Number 4, we have network operating system. Network operating system. What is it? Network operating system. Let's define it. A network operating system, this controls, its work is to control the computers running or participating in a networked area. Network operating system. I think I need to get this set of the old paper. I need it, I really need it. So network operating system, it enables, or it is necessary for computers that are running in a networked environment or a networked area. And most purposely, this is necessary, or it must be there for security purposes. Later on, we have a whole topic on networking. And then, of course, during that time, I'm sure we will come across some of these programs that are necessary in a networked environment or when we are building networks. And of course, today you know that we need a network operating system. In case you forget everything, just remember it is necessary for security reasons. Another type of an operating system, number 5, we have what we call real-time operating systems. Real-time operating systems. Real-time operating systems, these are programs. Remember we said an operating system is a program. We also said it's a set of instructions. So these types of operating system, they are needed or they are meant for real-time applications. And because we can't use a term to define another term, just simply say they are an operating system. Sorry, a real-time operating system is meant to run on applications with a fixed deadline. They run applications to fix deadlines. These are types of operating systems that runs on applications to fix a deadline. An example of a real-time operating system, nowadays we are running on smart television or smart network of televisions where you have to subscribe. Or you have that internet facility at your home where you have to subscribe. Or you have those many packages which you have subscribed to and you have to keep on renewing. Who makes sure that each time you don't pay, you don't access the facility? If you don't pay your DSTV, you don't have the facility. It is just gone. It's like somebody has switched on that function for you off. It is simply that, or the fact that such particular type of applications, they are run through technology with an assistance of a real-time operating system that is capable to fix deadlines for those applications, for those programs, for the channels that you have subscribed. The moment the system will suspect that you have not paid or it's due for payment, it just denies you the access because it is real time. Your deadline has just been passed on. You have to pay. Okay, that time when you make a reservation and for example, like a flight, and then you have not maybe shown up or maybe your time has lapsed, what happens? The ticket is closed because they are running on real-time systems. So we're talking about applications, look at all kinds of online reservations like the hoteling system, we have ticketing system, among many others, fixed on a deadline. Okay, let's just digest what we have covered. From the introduction, we defined what is an operating system. If you forget, just remember that is a resource manager. We have also said it's an interface. We have said there are two views in relationship to operating system. We have the user view, who just knows that the operating system is an interface to them. We have seen that there is the system itself, who views that the operating system is a resource allocator. Next, we have discussed on the functions, or why we are calling it a resource manager. Given you around 10 points, you can sing them like a chorus. We said we are not cramming, we are just understanding. So the moment you hear the functions of an operating system, you start drilling down communication, error handling, security, input, output, device management, process handling, job scheduling, as many as you can think of. And then, of course, the different types of an operating system. Think of real-time, think of time sharing, think of batch processing. We have distributed, we have the networking type of operating systems. I've given you around 4 or 5. You can look for 2 more. Next, let's understand in a nutshell the different examples. Examples of an operating system. I'm sure you have a smartphone or you have a laptop with you. Have you ever bothered to check on the type or the example of that operating system in your device? For all the Windows product, mostly we have a Windows type of an operating system. We also have kinds of Linux types of operating system. Many of the Chinese funny devices, they are operating on Android versions, etc. So what you do to understand the examples, any device that you come across, especially computer related, the versions or the classification, if it falls under a computer, just try and check on the type or the example of an operating system in that particular device. This will make sure that you can list as many as possible in terms of their operating system examples. Up to this point, hope you've understood. We're just about to end the class. That is always our Friday protocol.